Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aminuddin bin Hamzah, matric number 264248, and my group member is Sonia, anak perempuan Puventheran, matric number 262531. And today we about to present about our group project. Our group project is consists of is about of to find 3 minimum data sets and use 3 data mining algorithm to compare each algorithm for each data sets. So our data set, our experiment is consists of 3 data set and 3 algorithm, and we collect the data set from UCI machine learning repository, which is a collection of databases, domain theories, and data generated used by machine learning community like us for the empirical analysis of machine learning algorithm. And our dataset is consists of classification tasks. So let's continue to our first dataset, which is our first dataset is Algerian forest fires dataset. It has 244 data and consists of 12 attributes, and the target class will be fire or not fire. So it has 12 attribute, which is date, month, year, weather data observation, temperature in Celsius, relative humidity in percentage, wind speed in kilometer per hour, rain, which is total day in millimeter, fine fuel moisture code FFMC index, dust moisture code DMC index, initial spread index, and fire weather. So 244 instances that regroup of data consists of 2 regions of Algeria, which is namely Bajan region located at northeast of Algeria, and the Sidi Beth Albes region located in northwest of Algeria, which is 222 instances for each region. So the year of this dataset is 2019 and has no missing value. The second dataset name is Online Shoppers Purchasing Intention Dataset. It has 12,330 data and consists of 18 attributes, and the target attribute is to identify the shopper or the visitor of the mall end up shopping, which is true, or not, which is false. The attribute consists of administrative duration, informational, optional duration, product related duration, bounce rate, exit rate, page value, special day, operating system, browser, region, traffic type, weekend, visitor type, month, and if include the target is revenue. So it has 40 attributes that are numerical and 3 categorical, excluding the target of the class. So the year of the dataset is 2018. The third dataset is heart failure clinical record dataset. It has 299 data, consists of 12 attributes, and the target class name is death event, which is 0 and 1. Dataset contain medical record of patient who had the heart failure. The attribute is age, anemia, high blood pressure, diabetes, ejection fraction, platelets, sets, which is the gender, serum creatine, serum sodium, smoking, time, death event as the class of target attribute. This data set has no missing value, and the year of data set is donated is 2020. So we use the three algorithm to compare to analyze the data set, which is k nearest neighbor, KNN algorithm, decision tree algorithm, support vector machine algorithm, SVM. So for the k nearest neighbor algorithm, it was the supervised learning technique. It is simple, easy to implement, and can be used to solve both classification and regression method. Because our dataset consists of classification, it will classify the classes, which is false and true, 0 and 1. KNN algorithm assume the similarity between the attribute and available cases and put the new topic into the category that is most similar to the available categories. To use the KNN algorithm, we must select the number of k, which is number of nearest neighbor, and then calculate the Euclidean distance like this figure. If the new dataset, we must choose the number of k that we want to classify the new dataset. The second algorithm, which is the decision tree algorithm. Decision tree algorithm also supervised learning techniques. The decision tree is structured classifier where the attribute of the of a dataset are defined by internal node. Branches represent the rule of determination, and each leaf node represent the result. So decision tree contain of decision node and leaf node. Decision node are used to make decision, course, and then which will have the several branches, while the product of those decision is left nodes that are when they are leaf node, there are no additional branches. So the third algorithm is support vector machine algorithm. It is also the supervised learning technique. Support vector machine is mostly used for classification, but it also can be used on regression techniques. SVN algorithm goal is to book the best line or decision boundary by choosing the extreme point or vector that can segregate and dimensional space into group. So there are two type of support vector machine, which are linear support vector machine and linear support vector machine. My group member will continue to explain how these three algorithms used to analyze or to visualize the three dataset that have been collected.
Hi, my name is Sonia from Puventheran. My matrix number is 262531, and my part will be explaining about the experiment. Okay, so basically in our experiment, we will use three data set, which is the data set from the heart disease, and then a data set from forest fire, not fire, but fire burn in the forest Algeria, and then a data set of a shopper. So what we're gonna do for data visualization is we're gonna see on the distribution, and then we're gonna use tree algorithm, and we use for box plot also to see our visualization, and then we use tree model, which is the SVM, KNN, and tree. So we're gonna use a data sampler. Okay. Alright, so basically our in this data set, which is the first data set, is the online shopper intention. So we have like 17 attribute and one target, which is the revenue. On this, the false entry means that it's like is it the visitor gonna come or not? If not coming, which means that it's false. If true, then it's positive, which means that yeah, it's coming. So in this data set, there is no missing value, and the value of the data set is 12,330. So for the distribution, most of this data set, we can see that all the shape of the squid is on the right side, right squid. Most of the attribute you can see like all is about like right squid. So next I will proceed go to the box plot to see I mean like is it well classified for each features. For example, like in this data set, I see that most of it like is not well classified because of the mean over here. You can see that it's really not really separate, which means that it's really near, because a good features is the mean, the box plot must be separate. That what I mean is that well classified. You can see that in this data set, most of the data set like not really good in classify based on the true and false. You can see yeah, only like a few features that are okay, like but actually not really okay, but can see the separation from here, but just a small difference. And then next I will proceed go to the modeling, which is I'm using KNN, SVM, and tree. So basically we're looking at the accuracy and precise recall. Okay, how we're gonna choose our algorithm is that we will be looking at AUC and precision and recall, which is that if the highest AUC, and we'll be looking at the precision and recall, because we will using the one that these two value are having the same value, or like the difference between these two is not really not much. If have the model that having the same value for these two, we will choose that, because it means that it's well classified, it's well predict. Not, I mean, the missing classifier is not high. Like if means that okay, for example, like this one, like their recall and precision, if recall is higher than precision, it may have like incorrect classify. So even the AUC is higher than 3, but we're using the 3 because I mean the difference between these two is not much, and precision and recall having the same value, so I think 3 is the best model for this data set. So I will show you the proof that the tree is the best. Okay, you can see from this SVM. This one is confusion metric, which means that alright, for SVM we can see like the false, actual predict for the false and false is 86, and then false and false is 89 for the KNN, and then the 3 false and false is 95%. You see, this is like it's like higher than other model, and then the misclassify for this model is quite low than others. You can see like the other model is 10%, 12% for KNN, and then SVM is like 1380. So for me it's like quite high, so that's why we choose 3. So we proceed for this data set. The best model is 3. So that's how we choose our model. So next I will go to the other model, which is that Algeria forest dataset. So basically they have 13 features with no missing value, and the target is category, which is that fire and not fire. So like always, we use the distribution to see how is the shape of how's the shape of the distribution. For this dataset, the distribution quite okay, because most of it is like a normal distribution. You can see from here like it's normal. Like if have squid also, like just a little bit to the left. So this is like the perfect squidness, normal distribution. Only rain dataset, rain features that having the right squid, and FFMC to the left side, only like not fire having the normal. Same goes to DMC is to right. Most of, like in this data set is like we can see the different, like not all that having a normal distribution, but it's okay. So we're gonna see on the box plot. On the box plot, most of the features is like well classified. You can see like the separation between the mean for these two is like quite separate, so we can see that this data set, the features is well classified. Only the things that one that having not well classified and fire, but others are quite okay. You can see from that, yeah, it's well classified. And we proceed to the model, the same thing. So we're going to use SVM, KNN, and 3. So for the accuracy, we can see like the highest is the SVM, and also it's like quite nice because the purchase and recall, the values is the same as like I explained just now. But okay, like KNN, the purchases and recall is the same, but the AUC is quite a bit lower than SVM. So I will see on the confusion metric how it's well classified. Okay, so on the SVM we can see like fire and fire is 98, and for the KNN is 91, but for the 3 is 97. Okay, false and false, and then sorry, fire is not fire, but okay, for the best in this experiment we did is like the best is the SVM, because it's really important to predict saying that a is not fire. I mean the high is okay. The best is like 3 because okay, why I say 3 because it's really important to see, like, for example, if they predict saying that it's not fire but actually it's fire, something like that. Okay, sorry. The best model is SVM because has a data scientist will be looking at. I mean, confusion metric is really important to see the misclassify because okay, for example, they predict saying that the forest won't be not fire but actually it's fire. You can see like the I mean like the uh sorry the percentage of saying that it's saying uh not fire but actually it's fire is 0%. You can see from here, which means that it's good because okay, for example, like if in case if saying that it's not fire but actually it's fire, the misclassify is higher than not fire and predict not fire. I mean actual not fire is good because for example if we say that it's not fire and it's fire is something like it's dangerous, something like that. For example, like it won't give any, like, a sign to let the people around there to get ready, for example, like that. So for me the best model is 3 because the misclassify over here is quite low, which is like 0%, but SVM is 5%. It's like for me it's quite high. So the best model is still 3. Okay, we proceed to the next data set. So the next data set will be the heart failure clinic, and the target is death event, which is that 0 is for not dead and 1 is dead. So on this, like always, we open the features. So basically this is I mean the trend of each attribute. So we proceed to the distribution. Most of the distribution are mixed, which is that have normal and squid to the right and left. You can see from here it's various shape. So I will looking on the box plot. Okay, for the age, the it's well classified, but for the screen time post kinase is not really well classified, and the injection fraction is well classified, and platelets is not really well classified, and serum okay, not bad, and serum sodium is not really well classified because the separate is quite near. Okay, for the time. Okay, for the time is quite well classified. So we proceed to the next part, which is the using the same things SVM, KNN, and 3. Okay, for the test and score, the highest is the 3. Once again, it's the 3. And okay, and like okay, in this model we choose the one that having precision is higher than recall, because even the precision is higher than recall, this means that it's still I mean it's predict the classify is still correct, like the misclassified is still low. Same goes to like just now I mentioned about precisions and recall having the same value. The value of the misclassified is quite lower than recall having the highest than the value of recall and precisions having the high, which means that is the misclassified is quite higher. So I will choose 3 because the accuracy, I mean the AUC is quite higher than other model. So we will proceed to confusion matrix to see what is the best model. Okay, for example, uh, actual actual 0 and predict also 0, which means that date actual saying that it's date and predict saying it's also date. But for example, this part also we're looking on the, I mean I will take more focus on the predict saying that it's date, it's not date but actually it's date, this value 4.9. Okay, for example 3 is 4.9, KNN is 31, this is quite high, and SVM is 11. So the best model over here is that 3, because I mean the value of the I mean the value of the misclassifier for predict saying that it's not dead but actually is the patient is die. So the value is 4.9. This is quite lower than other models, so I will choose 3 because like as I mentioned just now, in health, especially in health department, it's really important to see is well classified, because I mean if they say that the patient is not gonna die but actually is die, that's mean is if the misclassified is high, that means the algorithm is not good. Because if we say that, okay, for example, if the model is saying that the patient gonna die but actually the patient is not die, is okay, because at least like the hospital they can like alert. But if the value over here they misclassify for saying that predict is not gonna die but actually is die, it's like it's not gonna give any sign to the health department to take any action earlier for the patient. So the best in this data set is like the best history. So in conclusion, we can say that the best model that we did for three experiment, three data set is that 3, because it's well classified than the other model, and about the misclassified also is like quite lower than other model. So that's all from us. Thank you.